Database performance is a critical component in building scalable applications. Most applications spend the majority of their time reading and writing from databases. The actual processing time tends to be minimal. This means if the database access is slow, then the application will be slow. One of the main ways that we optimize database performance is with indexes. So what is an index? Think of it like an index in a book. If you were looking for information, you could read the entire book. However, that's slow and inefficient. Instead, books often provide an index. This is a list of terms and which pages they can be found on. Database indexes operate in a similar fashion. They map search terms in a column to the location in the database. In CockroachDB, every table has a default index on its primary key. This is known as the primary index. It allows for efficient searches as long as you use the primary key. In our book example, think of the primary key as the page numbers. Although technically that's a monotonically incrementing integer which doesn't scale very well, so it's a good thing our book isn't a distributed database. However, in our non-distributed book example, if you want to get to a particular page, it's easy and straightforward to do so. You can look at the page numbers and quickly find where you need to go. Our primary index works the same way. To find a particular record, it is looked up in the primary index. But that assumes that you know something about the primary key. What if you want to search by a different column in the database? Back to our book example, what if you don't know what page you're looking for? For searches that don't use the primary key, we can leverage a secondary index. We create an additional index based on the columns that we want to search. If the primary key is like the page numbers of our book, then the secondary index is like the index at the back of the book. It maps from search terms to page numbers. In database terms, the secondary index maps from column values to primary keys. Once we have the key, we can use the primary index to find what we're looking for. As an example, in a table of users, an index on last name might point to the email addresses that correspond to that name. Assuming the email address is the primary key, it makes it easy to jump to the individual records. The create index command allows us to create secondary indexes. It requires the table name and one or more column names. Each call to create index establishes a new secondary index. Even if you provide multiple columns, you're only creating one index. When you look in a book index, you will sometimes find multiple words together. For example, for an index on this presentation, we might find the words index, book, and index, database. This is a composite index term rather than an individual term. It adds clarifying details to narrow down the search. The same applies in our database. Rather than creating an index on a single column, we can create a composite index that uses multiple columns. When we use a book index, we start by looking up the first term and then we refine our search based on the other terms available. Our database operates the same way. If we're using a composite index, we start by searching for the first column. Once we find it, we can take the results as is, or we can use later columns to help narrow down the search. Here, we have created an index on last name and first name. If we wanted to search for just the last name, we could, and it would use the index. We could also include the first name in the search to help narrow down the results. But if we search only for the first name, it will fail to use the index because it expects a last name. If we want to be able to search for both independently, then we need to create separate indexes rather than a composite index. So how do we know if we need an index? A simple solution is to use explain on the query. When you run explain, part of the output will indicate which index is being used, approximately how many rows will be scanned, and the type of scan being performed. In this example, we see that initially the index being used is the primary index, and it's doing a full scan covering 100% of the records. This is bad. For a large data set, it can be a very inefficient query. However, once we add an index, things change. Instead, it uses the index on last name and first name, and it only scans a small percentage of the table, basically covering records with the last name of Smith. That's the kind of search we want to see. It indicates that the index has been effective at improving the query. The key takeaway is, if you find yourself with database performance issues, it's often a good idea to run explain on the slow queries. Look for cases where your query is doing a full scan or is covering a large percentage of the records. Then add an index if necessary. But remember, indexes aren't free. Although it might be tempting to add one for every field, the database tries to keep those indexes in memory. Having too many can use a lot of system resources and may reduce your database performance. Instead, only add indexes where they are needed.